In this example, we have a piecewise function. Piecewise mean multiple pieces or multiple functions. In this example, we actually have three. 1, 2, 3. Your first one is a constant function, a single number. Your second one is x minus 2, and your third one is negative 3 over x. Each of these functions have parameters for your domain. So let's take a look at this one. X less than or equal to negative 4. So it means that x can be any number such as negative 4 because of the or equal sign. And it could be also numbers less than negative 4. So such as negative 6, negative 11, negative 12.1, or negative 20.5. Your second one is negative 4 less than x less than 4. So x can be 0, 2, or negative 3, but it cannot be negative 4, it cannot be 4 because these two does not have the or equal sign. The last one is x greater than 4, so x can be any number such as 10, 20, 31, 52, or 70.5, or 80.9, and so on. So when you're evaluating functions, you have to check your domain first in order to know which one to use. So in this example, it asks you to find f of 5. So you can do this in your head, but I'm going to write it out to visually see what you're going to do. So in your first domain, you're going to check. I'm just going to simply plug 5 into x to see. So 5 less than or equal to negative 4. Well, we already know that 5 cannot be less than a negative number since it's a positive 5. So this one is false. So let's check the second one. Negative 4 less than or equal to 5. So that part is true, but let's check the other side here. Less than or equal to 4. So we know that 5 cannot be less than 4. So this part is false. So we can't use these two. Now the last one, 5 greater than 4. Then we know for sure that 5 is greater than 4. So this one we're going to definitely use. So again, all I did was I plugged 5 into each of the x to check the parameters, which one is correct or which one we can use. In this case, we can use the third function because we know that this one right here, 5 greater than 4, is true. So we're going to use this function here. Now all we're doing is changing the x to 5 because it's asking us to find f of 5. So here, this x will become 5. Since there's no more variables, there's no more numbers to add, subtract, multiply, or divide, we're pretty much finished. So f of 5 equals negative 3 over 5. And that will be our final answer. Here we have another piecewise function. The first function is x squared minus 2. The second function, 3 over x plus 2. And the last one, negative 1 plus the square root of x. Parameters, x less than or equal to 0, 0 less than x, less than or equal to 4, and x greater than 4. Now it's asking us to evaluate f of 7/2. Well, since it's a fraction, it won't be easy to see which one to use. So what we can do is convert into a mixed number fraction or decimal. So let's work it out over here. 7/2. Now we know that 2 can go into 7 3 times, 3 whole numbers. So 2 times 3, that's going to be 6. So the work for that is 7 minus 6 over 2. This 6 is from 2 times 3, and this 2 is the denominator. What we are trying to see is how much left after we convert from 7 halves to 3 and see how much left from here. So 7 minus 6, that's 1 over 2, so 1 half. So 7 half is the same thing as 3 1 half. And to see that this is the same, just different form, 2 times 3 is 6. And then if I add the numerator, 1, 6 plus 1 is 7. So that's how we get 7 halves. In an improper fraction, this one right here is a mixed number fraction. Now, if I say I want to convert into a decimal, easy number to see when I'm using these parameters, 3 1 half is the same thing as 3.5. So now we have a decimal number, so it's easy to plug in. But if you're not used to this method, what we can do is use long division, just like in middle school. So 7 is divided by 2, so the denominator will go outside, the numerator will go on the inside. So here's our long division. 2 can go into 7 3 times. So 3 times 2 is 6. I'm going to put this in parentheses, subtract. I'm left with 1. So I have 3 whole numbers with a remainder of 1 over the denominator. So 3 1 half, which is what we have right here, or also known as 3.5. So let's take a look. Is 3.5 less than or equal to 0? No, that's going to be false. Here, 3.5 will be greater than 0, but also it's less than or equal to 4, so that's true. So I'm going to show that I'm just plugging 3.5 into these x here. 3.5 and then 3.5. Let's check if this one is true or false. 3.5 is greater than 4. So that's false. So we're not going to use that one. So the only one we're going to use is the second function, 3 over x plus 2. Now if we review the change from f of x to f of 7 halves, x is being replaced by 7 halves. So what we're going to do is, since we're using this second function, we're going to switch x with 7 half. Now even though we use 3.5, we only did that to see which parameters, which domain to use. So you don't have to use 3.5. Now the reason is, I'll show you why. So if we use the second function, 3 over x, and instead of x, I'm going to use 3.5 again. 3.5 is the decimal form of 7 half. Now, the reason I don't want to use a decimal is because since you have a whole number divided by a decimal, well, that's going to give you a decimal, and if you don't have a calculator to calculate this, it's going to be a lot more work to do. So instead, let's say we use 7 half. So I'll move this up a bit. So f 7 half instead of 3.5, I'm going to use 7 half. So 3 over 7 half plus 2. Now we have a whole number divided by a fraction. So there's something we can do. We can change it into a division problem. So 3 divided by 7 half plus 2. Now, if I convert this into a fraction, so what we're going to have is 3 over 1 divided by 7 half plus 2. So we have a fraction divided by another fraction. So, just like in middle school, we can work out division fractions, or we can change this into a multiplication problem. So the first fraction you keep the same, 3 over 1 times, we change it to multiplication and we're going to flip the second fraction. So 2 over 7 and then plus 2. So now 2 fractions multiply, you just multiply straight across. So it's going to be 6 over 7. 3 times 2 is 6, 1 times 7 is 7, plus 2. Now here's the issue. Fraction, whole number. We need to convert this into a fraction. Now, with a denominator of 7. So a number divided by 7 that equals 2. Well, instead of saying that way, what's 2 times 7? 14. So let me write 6 over 7 plus, again, 2 times 7, that's 14. So I'm going to write 14 on the top with a denominator of 7. What's 14 divided by 7? That's 2. Well, here it is. Draw the arrow here saying that 2 is the same as 14 over 7. Fraction form, whole number. So let me bring that work over here. So 6 over 7 plus 14 over 7. So this is a simplified, right here, this is the simplified form of this. This is the fraction form of the two. So if we combine, all you're doing is just adding the top number, so 6 plus 14, that's 20, and the denominator stays the same. Well, there's no more numbers, variables to add, subtract, multiply, divide, so we're pretty much done. So your final answer is going to be F 7/2 equal 20 over 7. So that's our final answer, and that's all you have to do. So I'm going to box this up, and then we're done. Now lastly, we have another piecewise function, 3 parts. First one, constant function 3 with a domain of x less than -3. Second one, negative x plus 3, domain -3 less than or equal x less than or equal to 2. Last, constant function -3/4 where the domain is x greater than 2. So when it's asking you to find f of 13 over 4, well, we have another fraction. Not going to be easy to plug it in, so what we're going to do, say let's use long division just like in the last example, convert into decimal. That way we can easily see which one to use. So I'm going to write 13 over 4 over here. So now we're going to use long division. So the denominator 4 will be on the outside, numerator will be in the inside. So 4 can go into 13 3 times. So 3 times 4 is 12. And I'm going to put parentheses. Subtract. 13 minus 12, that's the remainder of 1. So we have 3 whole numbers with a remainder of 1 divided by 4. So it's 3 1/4, also known as 1/4 going to be 0.25. So 3 1/4 is the same as 3.25 decimal number. So now we can actually use 3.25 in here. So I'm going to just write it in place of x. 3.25, 3.25, and 3.25. Now it's positive 3.25. So 3.25 less than -3 Well, we know that a positive is not less than a negative, so this one, false. 3.25 is greater than negative 3, but let's check this side. 3.25 less than or equal to 2. Well, the 3, the whole number right here, is greater than 2, so therefore it cannot be less than 2. So it will not fit here. Last one, 3.25 is greater than 2. Well, yes, it is greater than 2, so this one, it will work. So you're going to use the third last function because it fits in this domain, this parameter. So f of 13 over 4 equals to negative 4 over 3. There's no numbers, no variables to add, subtract, multiply, divide. So we're pretty much done. And I'm going to box it, our final answer. So that's all you have to do. Now if you need to review it, converting fraction into decimal, I would highly suggest to look for examples on YouTube converting improper fraction into decimal. But I would say the simplest form would be using long division, because you will be using long division in polynomials later on.